take number, I don't know, 30 or so. Anyway, ladies and gentlemen, welcome back. In this video, we will look into Eddy3D again. Why? Because we only did one video where we checked how to install it and then how the software runs within Rhino, and we did the first simple test script. That was pretty cool, but it deserves more, and we will look into it now a bit further. Another reason why I want to do this video is because Butterfly CFD hasn't updated for a long time, and I'm not sure if they will update it at some point. Eddy3D is, I think it's more user-friendly. So somebody who really struggled with Butterfly CFD will find Eddy3D much more simpler to handle, and we will go through that. And yeah, it's just super cool plugin, and it's free. I mean, what do you want more? So if you have Rhino and if you have Grasshopper, then there's no excuse. Let me quickly check if I'm not wrong and the Ladybug tools actually have updated it. So let's check food for Rhino. Yeah, food for Rhino. Let's check it out. So I'm checking here. Last version is 2019. So yeah, it's pretty much the one we used before. So that's why I'm not saying that Butterfly CFD is not good, and there are actually it has some components which you might not find in Eddy3D, but on the other hand, I think because it's Grasshopper, you can probably even combine it, so we can even install both because they're both free and use them. And you can use the same Blue CFD Core 2017 terminal, and you don't need anything else. So if you installed Butterfly, then there's a good chance that you can run Eddy3D without a big hustle of installing a lot of stuff. Without further ado, let's jump into Eddy3D. This is my screen, and I have some stuff here. So what you need is this. This is need to be installed. Please check my previous video about Eddy3D, then you know how that works. Okay, and now we start, and we need to start it as an administrator. That's for sure. You probably don't have that. Don't worry about it. And I only evaluating it at the moment, but it's a pretty cool software. It's a pretty cool plugin for Rhino, so at some point I want to actually make a video about it. Again, you need to look at the other videos to know how to install it, but if you have installed it successfully and you run Rhino as a administrator, then we can continue. And here we have Eddy3D. At the moment I don't have anything here. We will change that later, but let's see how that works. We're gonna repeat a bit what we did last time. So we can take this first thing here. That's a tool which basically just links onto your computer into the drive where Eddy3D is installed and where it has templates. So it asks right click, tells you everything you need to do. There you can basically, so this is very similar to Butterfly CFD with some differences, but it also has a probe plane. So you can base a probe plane, as you might know from Butterfly CFD, that would look like this. It's basically just a simple plane. It just creates a simple plane with these probe points. Let's kill that, we don't need that now. There is a wind direction. This is basically just lists with wind directions. Can have a look at that at some point, not today. And visualize wind vectors. That's basically the component which then colors your vectors, makes your vectors visible. And what we will look into is the simple wind analysis. And it's funny that it says here simple wind analysis with terrain, which is funny because the simple wind analysis also has a terrain. Let's see how that works. And actually, it's pretty cool because it's already set up completely, and I will also show how that works with why we now have suddenly a model in here. Well, because you can actually store geometry in a Grasshopper file. Pretty neat. And even the terrain model is in the Grasshopper file. How does it work? Well, actually, so what you can do is, like, for example, you have any container with geometry. I have this container, there's nothing in there, but if I want to put something in, I want to link this object here, then now this object lives in Grasshopper, but it also lives in Rhino. Now I can go here, right click, and then say internalize data. And now this geometry only lives in Grasshopper. And when you say send and save a script like this, then you basically can send an object with your Grasshopper definition. Pretty cool. And that's what they did here. So they have some geometry here. They have everything is set up. It's really cool. So instead of you trying to figure out how you set up the script, it's actually here. There's still some things we need to look at though. We'll look and most of these things in next videos because I want to explore myself. Just to explain a bit. So first we have the geometry and the boundary condition. So you set the geometry. It's basically here, and I show you how to then basically set your own geometry. We have the terrain that goes in here. So geometry, terrain, there is a slot for trees. There is the boundary condition. Boundary direction has certain slots for example, wind direction, for the wind, the atmospheric boundary layer. And then this creates your boundary. And what's really cool is that if I change this here, the wind direction, then it changes basically the boundary. Basically, it changes your wind direction by degree, which is super useful. And now we can see that my bounding box has rotated and the direction of the wind is from that side. Well, yeah, let's go back. So that was something which I couldn't get to work in Ladybug's butterflies if there was just a bug, and you had to rotate the model in order to make fine adjustments to the wind direction. And then we have the second object here is basically creates the domain. There's more in the block size. That's basically the size of your internal blocks, length, width, and height. And you can also look at the mesh. I don't know how that works, but it doesn't matter. So that's set up. Then the mesh in simulation here is where we set up all the basically where the mesh is set up. You can remember the Snappy Hex mesh. I love that name. And you can also look at the residuals here. It's all set up, and then you can see where it stores your wind analysis, and it has already a button to run it. And here we're gonna set, there's like how many CPUs you want to use for it. It already gives you the explanation on what you need to set here in order to use that slot. So for example, here it says number of CPUs set to -1, set the number of CPUs for the simulation automatically, so you don't need to do anything. And here it's about the accuracy of your test. At the moment we just leave it as it is. We will talk about the residuals at some point where we can actually see on how accurate our test is. And then we have the probe points. This is, I don't know what this is here. This is the plane. There's just a plane in there. It's basically internalized plane. That's it. There's nothing more. Here's the number slider on how many probe points I want on my plane. You can see here that already ran it. It already ran once because I had to check it out. So it already stored kind of one of these. It already stored one analysis on my computer, so that's why we can see some errors here. By the way, I want to turn this off, so I don't want to see this. No, I want to see the terrain, right? But I don't want to see the box shape, the domain box. So let's turn this off. And then we have the numbers. This is the generated probe points, and this basically links your. See, that's something which I was not sure how to do in Rhino CFD. In Butterfly CFD was how to cool the probing points outside the building mesh. So what this component does is basically saying whatever is inside these, all the probe points inside the geometry are excluded from the simulation. And then we have the result comes out here, and so basically this is where everything happens. This is the blue CFD, the simulation. Then we have the probe points, and then we want to make the probe points visible. And here we have the para view. I talked about the para view last time. This is actually the software in the background who deals with the whole thing, where you can look into your model and the simulation again if you want in a different way. But for that, please check my previous video. And then here we can just run it, and it's already set to the right name, the field name, the correct fields. We talked about fields in the Ladybug CFD videos. So there are different units, or there are different items you can test. And here is just a visualization of the wind. So let's run this again. I will turn the probe points off. Also, don't want to see this. And there's something not correct here. That's why we run it again. Anyway, let's also maybe try another. So yeah, I can just run this here. So this is also the test to see if everything works correct on your computer. It was pretty fast. We can have a look here. There was some calculation happening. It was all right. Now we can run this. It seems there's something wrong. What I'm gonna do now is I just clean everything and we do everything again. So I think that's better. We just start from a clean file. The only difference, you can't see the immediate result. That's a bit annoying. That was pretty cool in a Ladybug CFD or in the Butterfly CFD, where you actually see the result slowly emerging. That you don't have. Okay, hope this works now. Now we're gonna generate our, see, it worked. And here we can then actually adjust our output to make it visible, more visual pleasing. And we can average here the colors a bit better. It works pretty nicely. You can also change here the setting for the width. But I mean, we could easily also do this here in the same way as we did it before in Butterfly CFD. It's insane. I can't remember these names are all, too many animals, really. Too many animals. But yeah, I think it works really good. What is also cool is so for example, I would have a different plane. Let's say we have a different plane. Yeah, why not? Let's just do let's say I want to have a different plane which is cut through horizontally through my test model. Then I can just exchange this here. I will not delete this. I will just copy, and I place this in here. I place this here. Oh no, not clear value. I want to actually add my plane here. And now I can just reuse that. Now everything turns red, of course. but I can rerun this here. It should actually give me props. Yes. So because the calculation was already done here, you can, it doesn't work all the time, but you can just place another plane here. You could even probably have two planes. And again, you can also have volumes and so on. There are a lot of ways to do that. But I can also then check different levels. Now this didn't work. It didn't properly work, but I can rerun that again. And why, now you ask me, why does it work so fast now? It's because the whole calculation was already done. And now what I'm doing here, I just make the probe points or the vectors visible in these areas. As you can remember, the snappy hex mesh, they made a lot of small cells around the object, your test object. And they are all, the wind speeds in these cells are all calculated. We just don't show them all. We only show the ones which we choose through our probe point plane. And by the way, I had somebody ask me, my vectors are not, they're not 2D, they are actually, they have a direction even though they're in a plane. Yes, they are, because they actually show also the direction the wind goes. Because this is just, because we have it, we set up a plane with probe points, it doesn't mean that the wind has only the horizontal direction. No, it shows also the direction if it goes down or up and so on. I can imagine that you might run into a problem if you move your probe plane outside the boundary, the original boundary. Then you run into a problem. So if I, for example, do this, oh, still gives me something. That's pretty cool. Still gives me something. Although I doubt if this makes any sense. Let's try this here. Yeah, it still gives me something. Let's see. No, here. Oh yeah, because it's still inside. Okay, what if I pull it outside? Then it shouldn't work, and it should not work. Yeah, okay, now there's no, because there's no calculation done outside that boundary, that's why there's also no directions now. But what is pretty cool is that although this is not completely inside, it still works. It still gives me the probe points which are on the plane, which are inside the boundary. Let's see if I can also rotate that. You can also rotate that for sure. I'll rerun that. Yeah. Now let's look into how we can put in our own geometry. And I will use I will use this software. You don't need to do this. Any geometry you put in is possible. It's just need to make sure that you have translate them to meshes. But I will just show you a very cool. Another tool is a lens design where you can actually download stuff from the internet. Terrain and houses, buildings. This is not free software. I can't decide. Anywhere, it doesn't matter. Just decide something. Let's create mesh, create lens design terrain. I don't need that. Create buildings. Yes. Import. Okay, could be bigger. It's so cool. So now what we can do here is because these are already meshes, that's perfect. If you don't have, if you have a NURBS model, then I would say you do this, like you get your B-wraps here, and then you mesh it first. and then you need to join the mesh, and this is your final mesh for the geometry. The terrain, I think, is also need to be a mesh here, mesh. So because this information here, these are already meshes, so it need to be a mesh. If you have NURBS, you can translate them like this. As if I have meshes, you can just put your mesh container and then import all the models. You also need to join it, by the way. Let's do this first. I'm gonna hide this first here, and I'll also delete these because I don't need them. Now these are all my models. Maybe I will make it smaller. I don't need all of them. Maybe I just test the one here in the center. Also goes faster, quicker. And I just grab them all and put them here. Now I need to join them together because otherwise it doesn't work. So that is done. Then we can get our terrain. So then what else we need to do is we need to make sure that everything is connected the same way as we have it before. So we need to actually put the buildings here correctly. So that needs to be correct. And then in here I added a slider to basically have control over the domain. I'm not 100% sure if that works correctly. Yeah, let's see if that worked. Yes, yeah, it worked. So it's a pity that you can't see it better. Wait, let me try something. Interesting. Yeah, it works. It's not very clear. Looks very windy. But yeah, let's try this way. So now, okay, I did this. I can turn off my nice. So there's only one issue, is I had to rotate my terrain, weirdly enough, and I'm not sure why. First of all, let's delete this thing here. Don't need that. Yeah, but I think it's pretty good. Yeah, just okay. What I did here, I just added a division. Yeah, but I think it's pretty cool. So it also worked quite nicely with all the geometry. In the next video, we will examine this a bit more especially look into the boundary condition. We can even add a weather file here. We also look a bit more into how that works with the terrain, because that is a bit weird. It didn't actually work the way I wanted. Okay, let's repeat what we did. We got our geometry. You don't need to use lens design. It's just me trying it. Of course, you can try it as well. It has a 90-day evaluation period, and you saw it's very nice to actually download some terrain and simple massing for the buildings. That's quite interesting. So what we need to do is we need to import the mesh. We need to join the mesh. We need to link the mesh here into the simulation geometry, and here where we exclude the probe points from inside the geometry, and we set up a different plane that I showed you before. If you have B-wraps, you need to first change them to meshes and then join the meshes. That also works fine. Here I was like playing with the width and the height of the bounding box. We can have a look at that next time. So I have to actually put it upside down so to make it work. That means the orientation of the mesh is actually upside down. Anyway, it works, still works. Next time we also talk about the accuracy. When we set everything up, we can first see, we can look at the residuals. We'll talk about the residuals also, because that's important. It's very important. And we will then see what we need to do in order to run like a proper. And by the way, here this is the ParaView. I talked about this last time, and it's also nice to have this cleaning tool. Okay, I think that's it for today. See you next time.